Okay, so if you're seeing my screen, there are more parent functions than this, but this is the ones that you've listed here. Do you have a visual of each of these down? Like the first one,
Yes.
y equals x. The second one, y equals x squared. This one's U-shaped, goes down and then goes up. X cubed. It's always increasing. And then square root x, it's kind of it's the odd one. It has a shape where it starts at 0 and goes off to the right there. So you have to know that so well that you can get up, out of bed and be like, all right, I know exactly what these look like in the morning. Okay. The next topic here is transformations of functions, and it would appear that your instructor may give you a function and ask you to apply the transformations. So I'll snip one of those in, and we can work through some of these. So you would be given a graph of like x cubed. That's what your instructor shows here. You would be given this graph, and this is f of x. This is y equals f of x, yay. And it's like, well, what does this negative inside parentheses do? And you're supposed to know that it flips over the y-axis, not the x-axis, because it's inside, flips over this axis. And if that is not clear, it comes from this thing that your instructor provided at the top here, which is actually fairly good. Rarely see it, this clear. It comes from this snip of this. It's because of the like this right here is this one in this line here. It's in parentheses. Is that okay?
Yeah.
All right. So what does it look like? Well, it flips over the wax. So whatever's, it mirrors. This is your mirror right here in the middle. So this top part looks like this. This bottom part looks like this. So that's not too bad, I guess. Is that okay, Bish? Okay. So the next one that they give you is, and we're going to constantly refer back to this. Like if you have a printout of this, that that would be super helpful. If you don't, that's okay too. But it's like something we're just going to refer back to over and over again tonight as we're doing this. So f of 2x. Okay, the 2 is inside parentheses. So notice if it's inside parentheses, horizontal, 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 it's horizontal if it's inside parentheses. So this is your b. This is the b this time. This is your b equals 2. Okay, and it's a shrink if b is greater than 1, stretch if less than 1. So it's a horizontal shrink. So like, let's just say there's a point that's like 2 away. It's now 1 away. And same thing down here. Like, let's say it's 2 away. It's now 1 away. So it shrinks like that horizontally. Okay. Now, like your instructor goes to a lot of trouble here to show you a bunch of these horizontal ones, combining horizontal ones, then vertical ones, then combining vertical ones. Like what I guess you need to be able to do is let's say I tell you it's g of x equals -1/2 f of 3x minus 1 plus 2. Do you know what all of this does? That's where we're going. And do you think you can do that? Do you think you can list all the transformations of this? gonna grab
I
this.
think so.
Yeah, and I think you can too. You just have to follow this, which is kind of nice. So you start, you actually like if this is it goes in this order: 1, 2, 3, 4, 5, and then 6.
Mhm.
It's not like there's an infinite number of these things. So all right, so what about this one that's in parentheses? What is that? This x minus 1, what does that mean?
Um, that is a horizontal shift.
It's
Right.
right. It's right one. Okay. And then is there a b value? Is there a number out here? Yes.
Hmm.
So it's 3. So what is that? Is it a shrink or a stretch?
Shrink.
Should be a shrink, right? Shrink.
Mhm.
You might say horizontal. Horizontal shrink by 3. Okay.
Mhm.
It's positive, so nothing happens there. But now there's a 1/2 on the outside. So what does that 1/2 do? It's like 4.
Um, it's a vertical shrink.
It's a vertical shrink. So you got to get the right wording. Is it a shrink? Is it a stretch? And I can't help you with other than to remind you and say, what they are, but you have to know the words, really, really clearly. So then number 5, since it's negative, it's a vertical reflection. I prefer to talk about the axis, but this is over the x-axis. Okay, and that's
Mhm.
because of that negative right there in front. And then this +2, is number 6. Number 6 is a shift up 2. Did I go +2 or -2? Or up 2? Okay, so let's just say the parent function here was x cubed again. I'll draw it in red
Mhm.
here. Oh, that's really bad. I'm gonna do that. I'm gonna do one a little better. Okay, now like what's going on here with this new one? Well, it's going like the left, right, up, down are kind of a good place to start. Right 1 and up 2. Okay, and then it's shrunk vertically, and it's reflected across the x-axis here. So it ends up looking like something like this.
Okay.
Do you know if you're going to have to graph these on the exam?
I do not.
Okay. I thought we did one where you were doing a table. Do you remember that or not?
Mhm.
I'm not sure. I'm just sort of, going through that. Okay, let's do another
Yeah,
one.
I remember that.
Let's do another one here. And again, like you have this, I'll put at the top. You want to know this, really well. So let's say g of x equals 2f of -1/2 x plus 3 minus 4.
Okay.
I want you to give me the transformations, please, and take some time here to figure them out. But it's really important that you can do that on your own.
Okay. Okay, I think I'm done.
All right, so the first one is that it's left 3 units. That's this x plus 3.
Hmm.
The next one is a stretch. It's horizontal. I guess I need to say the stretch horizontal. It's a little bit it's a stretch because of that, but it actually ends up being a reciprocal of that number. So it's by a factor of 1/1/2, so it ends up being by 2. I don't know how much your instructor can cover that in class, but that's kind of a small little point there. This negative is a reflection over the y-axis. So you could say horizontal reflection. They're looking for that word probably, horizontal or vertical. The 2 out in front is a vertical stretch by 2. And then the last one is down 4. Were you able to get most, if not all of that?
Yes.
Okay, great. So the next type of problem that I could give you, or something that you could be asked to do, is I could give you the list of transformations. So I could say let's say f of x is square root of x. And I tell you that g of x has the following. It's right 2. It's a vertical stretch of 4. It's a vertical reflection. And then it's down 5. Could you write the equation with these things in mind?
Yes.
Okay, give that a try, please.
Okay, I'm not sure if it's right.
All right, let me go through it. So right 2 is square root x minus 2. The rest of these are on the outside. So 4 is the vertical stretch. The reflection puts a negative there, and then minus 5 on the outside. Did you get that or something close to that?
I was close.
Okay. The harder ones are when it's horizontal. So let's try one of those. So let's say I tell you that f of x is x cubed. And I tell you g of x has the following. It has a horizontal stretch of 5.
Mhm.
It is got a vertical stretch of 3, and it is down 7. Give that one a try, please. How are you doing on this one?
I'm a little stuck.
Okay, so the horizontal stretch of 5, this translates into a b value. B is the one inside here. It's the reciprocal. So it means that b is 1/5. And that's what goes inside there. So it's 1/5 x cubed. Okay, that takes care of that. The vertical stretch of 3 goes out here, and down 7 is on the outside here. It's these horizontal ones that are much more difficult, I think, in general to do.
Yeah.
So let's try one more and then move on to evaluating functions, combining functions. So let's say your f of x is x squared. And let's say g of x has the following. It is right 6. It has a horizontal stretch of 2. So that really means it's becomes a 1/2. Okay.
Mhm.
You wouldn't get that on exam, but then it would say vertical reflection, and then we'll go up 4. So give that a try, please. How are you doing on this one?
Um, I am finished with it.
All right, so the right 6 is x minus 6 squared. The horizontal
Mhm.
stretch, though, that has to be inside parentheses. So that's like this right here, where it's 1/2 parentheses parentheses, but then the other one squared.
Mhm.
The vertical reflection is a negative on the outside, and then plus 4 is the up 4.
Okay.
Let's see what else we can get through before coming back to that. There's
Okay.
just a lot. There's more here, and I just don't want to miss covering a little bit of everything if at all possible. So we're going to use this over and over again, this table and these functions, for some of the problems here. So let's just say I'm going to skip to like a more interesting one. Let's say your instructor asks you for g plus j of 4. So I'm snipping that in here, g plus j of 4. What that really means is you find g of 4, and then you add to it j of 4.
Mhm.
So you got equate, you got function, 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 table. Sometimes they even give you a graph to do this. So g of 4 is this square root function, which is kind of not. So this is the square root of 12 minus 2 times 4 plus j of 4 is, here's 4, here's j of 4, 72. Okay, so do you follow that? Like use the one that it specifies.
Hmm.
So this is this ends up being the square root of 4. This ends up being 2. 2 plus 72 is 74. So let's have you try one like this. Let me ask you to find h of -1 plus j of -1. How are you doing on this one?
I finished that one, but I'm not sure.
Okay, so h of -1 is using this middle one here. So it's -1 squared plus 6 times -1 plus 9. Notice I put them in parentheses. So that's 1 minus 6 plus 9. So that gives you 4. J of -1 comes from the table. That's for this one right here. -3 plus -3. So the answer is 1.
Okay.
Let's do a couple more. Yeah, I'll send you these notes right away at the end, so you don't have to worry about getting it all down right now. But let's look at some of the other possibilities here. G and J. Yeah. Okay. So this one, we're doing this for the notation. Like what does it mean when the numbers are, or the letters are smashed up against each other? This is G of 4 times J of 4. So you get that number, and you multiply them together. Okay.
Okay.
So do that with your table there, please.
I have a question. So how do
Of
you
course.
know which equation to pick?
G is right here.
Oh, okay.
If it said H of 4, you'd be using the middle one. I of 4, you'd be using that one. Like I could, let me, and I
Oh,
might as well,
okay.
I mean, so it's no more complicated than that, or it's not that complicated. You just have to know the letters actually mean what they mean.
Okay.
How are you doing on this one?
I think I did it.
So the first one, you're using the square root 12 minus 2 times 4. That ends up being the square root of 4 again, that's 2. And then j of 4 is 72. So that's 144. Is that okay?
Okay. Can we do one more?
Yeah, absolutely. Because the last one here is probably the most important. It's the composition, meaning like this is the one you'll probably get on the exam. So composition, oops, sorry, let me get this where it's not moving on. Stop moving. Okay. This one is it's h of j of 0. H of j of 0. And it means first find j of 0. That's the inside one.
Mhm.
So what is j of 0? Here's j in the table.
0.
It's 0. So now you use that as like instead of j of 0, it becomes h of 0 because that replaces it. So h of 0 is this one here.
Mhm.
So to get h of 0, you put 0 squared plus 6 times 0 plus 9. So this ends up being just 9.
Mhm.
Let's do another one because I don't know if that was clear. We got time here. Okay, so let's just say I asked for h of g of 2. Sorry, of 4. What are you going to do first? What is the first thing you do?
Um,
The inside.
multiplied. Yeah.
So the inside, not multiply, g of 4. You have to first go and figure out what is g of 4. That's your first step. Right? That's this inside part. And whatever that number is, you're going to use it.
72.
G of 4. Which one is g?
Oh, okay. The first one.
Yes. So it's the square root. Again, we've done this a bunch of times. What does that become?
2.
2. So that number replaces g of 4. Like instead of h of g of 4, you do h of 2. Because g of 4
Okay.
is really 2. That's why it goes in here. So you go find your h function and use that now.
Oh wait, so then
So use this x squared plus 6x plus 9.
oh okay.
So
So
instead of x, you put in 2. So what does this become?
25.
25. Good. Okay, so and just in the time, I'd like to just move to 2.3, analyzing graphs, and then we can come back to this if there's more time, if you're okay with that.
Mhm.
All right. So next thing your instructor does here is throws up just a graph. It's a little bit odd. It's showing that it like ends here, which is really weird, but that's your instructor's.
Mhm.
It's showing up, down, and then back up. We know some of these points. This is 0, 4. This point right here is put an arrow to it. It's -1, 6. And it says a complete analysis. So let's just start with some simple things like domain and range. What is the leftmost x value? And we'll say that that's like -4, -5-ish.
Okay. So -4.
Domain is -4, 2. How far to the right does this go?
0.
Forever. It goes to the right
Oh,
forever.
okay.
That's what this arrow, up arrow means. Now
Okay.
your range is what's the smallest y value?
-5.
Okay. And then how far up does it go?
Infinity.
Yes. Okay. Okay. What are the x-intercepts? Looks like there's one right there. Where would you estimate that to be?
3.5.
-3.50. Yep. How about your y-intercept? Where does it cross the y-axis? So goes up, down, so you're right there.
0.4.
0.4. Okay. The next thing is usually like increasing and then decreasing. So increasing means it's going up and to the right. So do you see how it's going up and to the right all the way to this point here?
Mm-hmm.
What's the x value here and here?
-4, -2.
Right. And then it goes down, so it's not increasing, but here at 0, it starts increasing again, and it's increasing forever.
Infinity.
Yes.
Okay.
But where's it decreasing? Well, we just said it's basically wherever it's not increasing. Decreasing here from this x value to this x value, from -2 to 0.
Okay.
Okay. What other kind of analysis do you remember from class? Like what else could they be asking?
The zeros.
So we got those.
Oh, okay.
How about horizontal asymptotes? This one
I don't
has
think
none.
so.
Okay. What about vertical asymptotes?
None.
These has none. Yep. Sometimes they ask about boundedness. You heard that in class?
No.
Okay. All right, let's go to the next one here. And let's do some of the same kind of analysis. Okay, so it says to assume there's arrows, like that means that goes there and there, there and there. And then there's a vertical asymptote there and a horizontal asymptote there. Okay, so what is the domain of this function? And the only restrictions are vertical asymptotes.
The domain is
Like what's the only restricted value?
what?
See at -4, there's a vertical asymptote.
Mm-hmm.
That's a restricted value. So it can't include that. So it's everything except for that value is your domain.
Okay.
Your range is somewhat similar. Like it goes down to -infinity here, but it never crosses 0. Do you see that? Like it never goes across that. So
Mm-hmm.
it approaches it just like this vertical asymptote, but it never touches it. So like it approaches 0 and then it jumps to the other side and goes up forever.
Mm-hmm.
It sounded like maybe you haven't seen this before.
Yeah, I haven't.
Okay. All right. Does this have a y-intercept? So it's wherever it crosses the y-axis. So kind of right there. What do you
Yeah.
see there? So 0, maybe -1/2. Does it
Mhm.
have an x-intercept? Does it cross the x-axis anywhere?
No.
No. Okay, now let's look at where it's increasing. So increasing means it's going up and to the right. Do you see how this part on the left here is always going up and to the right?
Mhm.
So that is increasing. It's increasing from -infinity to that x value -4. Now, how about over here? Is this going up and to the right?
Yes.
Yes. So -4 to infinity as well. This one does have a vertical asymptote at x equals -4. That's right here.
Mhm.
And it's got a horizontal asymptote at y equals 0 because it like approaches it at the end.
Mhm.
Okay, let's do a couple more of these function analysis stuff because I don't know if that was clear. Yeah, I mean, there's a lot more here, but we'll do what we can here in the time we have remaining for this lesson. Okay. So they're giving you two functions. And the first thing that they're asking for is f bubble g of x. And this bubble right here means composition.
Mhm.
So you saw this earlier, it's f of g of x. So you have to do this first right here. And
Mhm.
then you take whatever that is. So notice how g of x is really this. So
Mhm.
instead of g of x, you write 1/2 x.
Okay.
Because g of x is 1/2 x. Now f of x is given here on the top left. So wherever you see an x there, you replace it with x squared. Like normally you'd write 2x squared plus 4x. But what I'm telling you to do is wherever you see an x, to replace it with 1/2 x. And wherever you see an x again, to replace it with 1/2 x.
Okay.
Okay, and now you got to simplify. Okay, so 1/2 x squared is 1/4 x squared.
Mhm.
4 times 1/2 x is 2x. And you multiply this 2 in and you get 1/2 x squared plus 2x.
Okay.
Okay, now so let's try it now with some numbers. Because I don't know if that was clear, and you may get one with numbers. So let's do f bubble g of -4. So this means f of g of -4. This is what you do first. You do the g of -4 first. So here's g of x. G of x equals 1/2 x. You want g of -4. So you're going to put -4 in for x. What does that equal?
-2.
-2. Excellent. So now that's what you do first. So instead of g of -4, it's really f of -2 because g of -4 is -2. Do you see how that's there?
Mhm.
So now what do you use for f? You were asking me this earlier. We'll use the f one, the f function here.
Mhm.
So f of -2, sorry, I got, let me scroll up here just slightly, is 2 times -2 squared plus 4 times -2. Right, wherever you see an x, you put in that -2. So that's 2 times 4, because you got to square first, plus -8. 8 plus -8 equals 0.
0.
Okay, so let's try another one here. We got time. Grab this again. So let's do G bubble G of X. So this means G of X. And you can do this. You can nest as many functions as you want inside the other. It's just like you have an inside function, so on. So G of X is 1/2 X. So this is really G of 1/2 X. Okay. So instead of G of X here, you put 1/2 X. Now you might think to put the same thing here, but what this means is wherever you see an X, you put in 1/2 X. So instead of X, this goes in here. It's 1/2 X.
Mm-hmm.
So this equals 1/4 X. Because it's like you take this function and then you put it back inside for X. That's what we did here, back inside for X. So let's say I asked you for G bubble G of -12. This means G of -12. So you start here. This is first. What is G of -12? It's 1/2 of -12, which is -6. So instead of this G of -12, instead of all this becomes G of -6. You take this number and right there. Well, what is G again? It's 1/2 of whatever the X value is, which is -6. So that becomes -3, and that's your final answer. Okay, let's take a short break. Well, you'll want to use that other Zoom link for the next lesson. I can gladly go back to this, but you said you wanted to work on physics, so I guess we'll work on that next.
Okay, thank you.
We'll see you in about 10 minutes. Thank you. Bye now.
Okay, bye.